Learning is always fun. Hi grade 10! Welcome to another learning session in Earth Science 10 with me, Teacher Jem. It's a great day to learn something new. So what are you waiting for? Grab your learning activity sheet and let's begin. Earthquake is one of the most devastating geologic events that happen across the world. We've seen the destruction they unleashed. Some of us may have lived even through one. And we know they can be deadly. But where does this force come from? While we may think that we're standing on solid ground, the earth beneath us is completely unstable. Earthquakes are vibrations caused by rock breaking under stress. Rock breaks and moves along an underground surface called fault plane. This movement is sudden and releases a lot of energy transmitted as seismic waves. The point where an earthquake originates is called focus. The location above this on the Earth's surface is the epicenter. Earthquake creates three types of waves: P wave, S wave, and surface wave. P waves or primary wave are compression waves. They travel the fastest and the first wave to be detected. S waves or secondary wave are shear waves that move in a side-to-side motion. They are the second type of wave to be detected. The last is surface wave that rolls along the surface of the earth. They are the most destructive type of waves as they make the ground move up and down, but they lose their energy the fastest and can travel far. Lesson number 2. Triangulation method. Today's lesson is anchored to the most essential learning competency, which is to describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory. Specifically, compute mathematically the distance of an epicenter and locate the epicenter of an earthquake using triangulation method. Let's begin for our first activity entitled Unscrambler. You are going to rearrange the jumbled letters to form words. For the hint, words that can be formed were all related to earthquake. First word, Sokuf, the source of an earthquake, an exact location within Earth where seismic waves are generated by sudden release of stored elastic energy. Answer please. Correct. The answer is focus. Next word, Entrepise, the point on the surface of the earth directly above the focus. Answer is epicenter. Next word, Rima-Pri-Vewa, the fastest type of seismic wave that arrives first in a seismic station. The answer is primary wave. Next word, Considari-Vewa, the second type of seismic wave to be recorded in a seismic station. The answer is secondary wave. Next word, Algmite, the time difference between the P wave and S wave. The answer is lag time. Last word, Triangulation, a method that uses distance information from 3 seismic stations to locate the epicenter. The answer is triangulation. Did you enjoy the activity? I hope you scored well. You may take note of those terms to better understand our lesson for this week. For the practice exercise, please get your LAS and read the direction. Compute for the lag time and distance of the epicenter from the seismic stations of the given hypothetical earthquake. So how do we compute for the lag time? The formula is the arrival time of S wave minus the arrival time of P wave. For instance, we have the given in Batangas, the P wave arrived at 8 seconds while the S wave arrived at 34 seconds. So what we're going to do is 34 seconds minus 8 seconds. And that is equal to 26 seconds. So this is now the lag time for Batangas. In your learning activity sheets, you will also see a table similar to this one. Complete the table by answering the lag time for Palawan and Cagayan de Oro. How do we compute for the distance of the epicenter? The formula is D is equal to TD divided by 8 seconds times 100 km, where D is the distance, TD is the time difference between P and S wave or the lag time. This formula is suitable because the interval between P and S wave is 8 seconds per 100 km. So using the data we have obtained for the lag time for Batangas, we may now substitute the given to the formula. T is equal to the time difference, which is 26 seconds divided by 8 seconds. Cancel out the unit second, which is equal to 3.25 times 100 km is equal to 325 km. So this means that the Batangas seismic station is 325 km away from the epicenter. Since 325 km is too big for the printed map, the computed distance must be converted to centimeter based on the scale provided in the map. So in this case, 1 centimeter is to 100 km. D is equal to, let's now convert it to centimeter, 325 km times 1 centimeter divided by 100 km, cancel out the unit kilometer, and we will have 3.25 centimeter. So using also the lag time that you have computed earlier for Palawan and Cagayan de Oro, you may now solve for the distance of the seismic station in Palawan, the distance of the epicenter from the seismic station, the converted scale, and also for Cagayan de Oro. So what you will do next? Choose one of the recording stations and measure the computed distance on the map scale. Center your compass on the station you have chosen. For example, in Batangas, draw a circle and the radius of the circle is equal to the estimated distance from the station to the earthquake. So you're going to repeat steps 1 and 2 for the rest of the seismic station. After doing that, you can actually locate, or you should get 3 circles that intersect or nearly intersect at a point. This intersection is the epicenter. In this case, in Masbate. From this lesson, you've learned triangulation method, a method that uses distance information from 3 seismic stations to locate the epicenter. Further, in triangulation method, at each station, we can draw a circle on a map that has a radius equal to the distance to the epicenter from each seismic station. These three circles may intersect or nearly intersect at a point that we call the epicenter. Locating the epicenter, remember the following steps. And lastly, so the question is, why is determining the epicenter important? It provides data in identifying the areas which are prone to earthquake so that necessary precaution will be taken. Basis for planning post-earthquake rehabilitation and relief measures. Serves as future reference to be used by the government in terms of infrastructure approval and building codes permit. Further, determining the epicenter provide information that identifies distribution of active faults. The basis of scientists in dividing the Earth into plates. Civil engineers may use this data to help them create safer structures that are less likely to sustain damage during earthquakes. Let's check your understanding by answering the evaluation in your learning activity sheets. And that's it for today. I hope you had fun and most importantly, you learned well. This is me again, your teacher in science, Mrs. Jamailin E. Cornal. Till our next episode.